Hi, today we're looking at section 5-8, point slope form. Remember to take out notes, something to write notes on, pause the video at any time, and complete the check it out questions. We have two learning targets today. I can graph a line and write a linear equation using point slope form, and I can write a linear equation given 2 points. So point slope form is y minus y sub 1 equals m times x minus x sub 1, where just like in our slope-intercept form, the m is our slope. In this case, we're given a point now, x sub 1, y sub 1, and we just plug those values in to our point slope form, and that's the way it stays. So let's look at an example. We want to write the equation in point slope form for the given line that contains this point and this slope. So again, point slope form is y minus y sub 1 equals m times x minus x sub 1. So let's just plug our values in. So we have y minus y sub 1 is 1 equals our slope of 1 over 6 times x is 5, or times x minus x sub 1 is 5, and that is our equation. Our second one, we have y minus y sub 1 is 3 equals our slope of negative 4 times x minus x sub 1 is 0. And you may leave it in this form, or you can simplify to this, but this form here is perfectly acceptable. And our last example for this one would be y minus y sub 1 is a negative 4, so put parentheses around the negative 4, equals our slope of 1 times x minus x sub 1, which is a negative 1. And again, do parentheses just so we don't get confused and keep it a negative. Again, in this case, you could simplify to y plus 4 equals x plus 1, or leave it in this original form. Now it's your turn. You have 2 check it outs to do. Bring any questions to class. Now we're going to look at the equation. This equation here is in point slope form. We want to graph it. So let's pull out the information that we know. Again, keeping in mind y minus y sub 1 equals m times x minus x sub 1. It's our point slope form. So now that tells us that the 1 here corresponds to our y sub 1. The 2 is our slope. And the 3 is our x sub 1. So our point we have would be at 3, 1, and our slope is 2. So just like graphing in slope-intercept form, we start with our point. Point's at 3, 1. Then our slope is 2, so we go up 2 over 1, or we can go down 2 and over 1, and then draw our line. Okay, so connecting the points. We connect our 3 points. Again, you should have 3 points for a line. By definition, we need 2, but let's go with 3. Connect them and arrowheads on both ends of the line, because it is a line, and goes on forever in each direction. Here's another example. Again, our point slope form, y minus y sub 1 equals our slope times x minus x sub 1. So again, point slope form allows us to pull both of those pieces of information out. 4 is our y component, our coordinate, 3/4 is our slope. Now we look at our sign change here. So in order to get a positive 2 here, our x sub 1 had to have been a negative 2. So our point's going to be at negative 2 and 4, and our slope is at 3/4. So let's go ahead and graph those points. Okay, so we plotted our 3 points. We started at the point we're given, negative 2, 4. We went up 3 over 4, down 3 over 4, and then drew our line in. Now let's look back here again, just to make sure you understand. It says positive 2 here, but we end up with a negative 2. We could rewrite our initial equation as y minus 4 equals 3/4 times x minus a negative 2. So therefore, we're going to end up with a negative 2 for our x coordinate. So when you ever have a plus, your coordinate's going to be a negative, because a negative times a negative is going to be, or negative times negative is a positive. And here's our last example. We have y plus 3 equals 0 times x minus 4. Here it's plus. So remember what we said in our last example. Let's pull out our points. our x-coordinate is going to be 4. Our y-coordinate, if we rewrite this as y minus a negative 3, and then our slope is here. So we have 4, negative 3 is our point, and our slope equals 0. Remember, a 0 slope means we have a horizontal line. A horizontal line has to go through the y-coordinate, so it's going to be going through negative 3. Let's graph that. So here we go. We plotted our point at 4, negative 3, and since the slope is 0, we didn't go up or down any, so we just draw our horizontal line in. Now it's your turn. You have this again. Watch the signs here. The point slope form has y minus and x minus. Same thing here. Always watch your signs. Now we're going to this third example. Write the equation that describes each line in slope-intercept form, given the slope and a point. Okay, so to refresh your memory, slope-intercept form is y equals mx plus b. Again, m is our slope, the same as in our point slope form. We don't know our y-intercept though in point slope form. So here we've written out point slope form because we're given a point and a slope. Plug our values in. So our 4 goes for our y, 3 is our slope, and negative 1 is our x pair. We solve this equation, so we distribute the 3 to every term in parentheses. We end up with solving it for y equals 3x plus 7. And that is now in slope-intercept form. So when you solve point slope form for y, we get it in slope-intercept form. Now, this example, we're given 2 points. And we want to again write it in slope-intercept form. So we can take these 2 points, find the slope, and then put it in a point slope form and solve. Okay, so first off, we find our slope. So our use slope formula, change in y over the change in x. So we did this minus this, and 2 minus 4, ended up with our slope being 2. So now we're ready to put it into point slope form. You get to pick which either point. I chose the one without any of the negative coordinates. So I plugged in 4 for x and 1 for y and 2 for our slope. Again, distribute the 2, solved it for y, and now we are in point slope form, or I'm sorry, slope-intercept form. And our last one for this one is, given our 2 intercepts, we want to again write in slope-intercept form. We're given our y-intercept, so all we need to do is find our slope. Okay, so remember we keep telling you or asking you to put your intercepts, write them as ordered pairs, because now the x-intercept is written as 1/4, 0, y-intercept is 0, 1. So we can find our slope, taking this 0 minus 1, and then 1/4 minus 0. And end up with our slope to be negative 4. We end up with negative 1 divided by 1/4, divided by a fraction, and multiplied by the reciprocal. And so now we have our slope. We can plug our slope in. We have our y-intercept. And here is that equation for the line written in slope-intercept form. You have 2 check it outs to do. Good luck. Now we're going to use 2 points to find the intercepts. We want to write the equation again in slope-intercept form given those 2 points. Okay, so we're given the 2 points. So first off, we need to find the slope. To do that, we take one of the points, and when I took this point first, subtracted the y-coordinates and then the x-coordinates. Again, remember that going bottom up, going this way, you should have an ordered pair of 10, negative 3, 5, negative 2. So yep, we got them in the right order. We end up with our slope being negative 1/5. We can write that now in point slope form. Substitute in, again, any of the ordered pairs. I chose the ordered pair 5, negative 2. Solving it for y, we get y equals negative 1/5 x minus 5. So now it's in slope-intercept form. From here, I can then find the x-intercept. Remember, x-intercept, we set y equal to 0. So 0 equals negative 1/5 x minus 1. We add 1/5 x to both sides. Multiply both sides by 5. We get x, the x-intercept be negative 5. Our y-intercept, we set our x term equal to 0. So 0 is plugged in for x, solving for y, which makes this whole term go to 0. we get y equals -1. And those are our two intercepts. You have a check it out to do. Our last example, the cost to stain a deck is a linear function of the deck's area. The cost to stain 100, 250, 400 square feet are shown here in this table. We want to write an equation slope-intercept form that represents the function. So these here are ordered pairs. This would be our x, and this is our y, because the cost depends on the area. So let's go ahead and find our slope, plug in an ordered pair in point slope form, and then solve it for y for slope-intercept. So we have to, again, to write slope-intercept form, we have to find our slope. So I chose this ordered pair and this ordered pair to use. So I did the y's, 525 minus 150 over 400 minus 100. So our slope is 1.25. Now we have a point to plug in our point slope form, and this time, again, I chose the point 100 and 150. So plug y minus 150 equals 1.25 times x minus 100. Solving for y, this is now our slope-intercept form. And then for b, when x equals 75, plug in 75 for our x, solve for y. It's going to cost $118.75. Here's your check it out to do about newspaper ads. So in summary, point slope form easily gives you a point and the slope as the name implies. To graph it, as we do with slope-intercept, start with the point you're given and then use the slope to rise and run. When we have point slope form, when we solve it for y, we end up in our slope-intercept form. So these are just two ways to graph linear functions. So good luck bringing questions to class.